In this class, we will be learning about pointers. Pointer is a derived data type that can store the address of another variable. Basically, pointer is derived data type which can store the address of another variable. So this is very important point we are all supposed to remember. Store the address of other C variable as mentioned here. The pointer variable will holds the address of a variable. So in case of our normal C variable, for example, I am declaring a variable as int C and I am assigning value 5. Means what will happen, a memory space of size 4 bytes will be allocated with the name C, and in that memory location the value 5 will be stored. But in case of the pointer, if the same variable C is considered or declared as a pointer, instead of storing the value, it will store the address of the another variable. Okay, we cannot just like that assign a value 5 to this particular variable. So we will be assigning the address of the another variable. For example, if the variable declared as C as like here, in C we have declared the variable as C, and we are assigning that variable C to the address of another variable. For example, you can consider it as N. So in such cases, the variable C will be denoted with the symbol or an operator called a star. So we call this as an operator as a referencing operator. Okay, so pointer is basically a derived data type. We can access and manipulate the data stored in that memory location where pointer is pointing. So that now the memory location of C is allocated as like this. So in this location, the C will contains the address of the variable N. Okay, so we are all able to differentiate the value and its address, right? For example, 10xx84C. So like that. So this would be the address of a variable N. Okay, so as the pointer stored the memory addresses, its size is independent of the type of data they are pointing to. Okay, then let us get into the syntax of the pointer declaration. So as we have seen in our previous slide itself, the pointer variables can be declared with the help of the pointer dereferencing operator. Okay, so here the dereferencing operator, what we are denoting is star. Okay, so this dereferencing operator is helpful to differentiate the variable, differentiate the normal variable from the pointer variable. Okay, we call this as a pointer variable 2. Okay, so data type star PTR is the representation of the pointer variable. So for example, if you are declaring the pointer variable as PTR, for that data type may be anything. It may be an integer or it may be a float. Here I have taken the data type as integer. I am declaring as like a normal variable. So in order to make it as a pointer variable, the pointer is denoted with the pointer operator star. Okay, so here the pointer is denoted with an operator star. Okay, so by the way, the normal variable and the pointer variable are getting differentiated. Okay, so this is the pointer variable as we are able to differentiate it by its representation along with its additional dereferencing operator, that is star. Okay, so here in this example, 1 minute. Here we are supposed to include the operator star here to convert the operator as a pointer, convert the variable as a pointer variable. So PTR is the name of the pointer. Okay, data type is the type of data it is pointing to. So what type of data it is going to point to. So that is what the important point we are supposed to remember here. So PTR, obviously it will be the name, but here the data type is the type of data that particular pointer is going to point. Whether this pointer is going to point an integer data, okay, or it is going to point a float data, okay, ampersand f or something like that. For if the variables are declared as int n and maybe float f means, so this pointer we can have a pointer as pointer 1 and a pointer 2. So pointer 1 may point the data of type integer, pointer 2 may point the data of type float. Okay, so this is the representation of the assigning values to the pointer. So based on the data type of the based on the data type which the pointer is going to store the data, we are supposed to declare the pointer variables too. Okay, so if it is going to point out the address of the integer variable, means here it should be declared as int. Otherwise, it can be of other data type based on the requirement. Okay, then how to use pointers? So pointer can be used in 3 different ways. Okay, so one is using by declaration and initialization. Third one is dereferencing. Okay, so these are the 3 ways or 3 steps to be followed for the effective utilization of the pointers. So we can use the pointers based on the applications as like this. Okay, so here the pointer declaration, let us see. So the in pointer declaration we only declare the pointer, but we do not initialize. We will just declare a pointer. Okay, so in this example here we use the dereference operator for representing the variable as a pointer variable. So in this example, what will happen, a memory of type integer will be allocated with the name as PTR. The location, memory location is assigned to the name as PTR, and its size is 4 bytes, and its size is 4 bytes. Okay, so this is the simple pointer declaration. Okay, the next one is pointer initialization. So obviously, as per the name indicates that we are able to initialize the pointer. Okay, so how we are able to initialize the pointer? By assigning the address of the another variable, we can initialize here. Okay, so in this content, the pointer initialization is the process where we assign some initial value to pointer variable, some assigning some initial value to pointer variable. So we generally use the address operator for initialization. We call this operator as the address operator. This operator will always fetch the memory address of the variable, and then it store it in the pointer variable. Okay, so this is the important point about the pointer variable ampersand. So here we are declaring a variable of type integer, and we are simply assigning value 10 to it. Then we are declaring this is a declaration of normal variable. We are not using any pointer here, so that it is a normal variable. And this is the declaration of pointer variable. Okay, declaration of pointer variable. So here the variable is named as PTR. Okay, so how we are able to identify, differentiate it with the help of this dereferencing operator. Then we are assigning values to the variable. Okay, pointer variable, we are assigning value. So how we are able to assign? By assigning the address of the variable where to the pointer variable PTR. So while we are doing these operations, what will happen means, so here the operator will get the memory allocation initially. So let us look into the this structure here. So initially we have declared a variable. Its name is var. Okay, its name is var, where we assigned a value 10. Okay, so in this this particular variable, we will be considering here, 1 minute. So in this particular variable, we will be assigning the value 10 to the location where the variable var is declared. Okay. So for example, here I am considering the variable address as 1010. Okay, let me take this is an 1010 is the address of the variable. Then I am declaring another one variable called PTR. Another variable is what? PTR here. So this variable PTR will be stored in the another variable is PTR. This variable PTR you can consider its address as 1020. For example, I am assigning address as 1020. And what I am doing is, due to this assignment statement, PTR equal to address of variable, means this variable PTR will store the address of the variable var. That means this particular variable PTR will point the address of the variable var. Okay, so this is what the representation, or this is what the variable assigning to the point values assigning to the pointer variable. So now the pointer variable points the address of the variable. Okay, so then when we are trying to print the sorry, when we are trying to print the content of this particular address variable, so what will happen? This variable will be represented with the dereferencing operator as PTR. So PTR means what? PTR, content of the address of PTR. So content of PTR. So content of PTR means what? So PTR contains the addresses 1010. So that content of the address 1010. So what is the content of the address? So content of the address is obviously the value of the variable where it is 10. Okay, so by the way, the pointer variable points the address of the another variable. The dereferencing operator helps to get the content of the pointer variable. Okay, this is pointer initialization. Okay, then the third operation what we are able to perform here is the dereferencing that we have already shown with in the previous slide itself. Again, we are seeing here with a little different representation. Okay, here dereferencing pointer is the process of accessing the value stored in the memory address. Okay, in the pointer. So here for dereferencing, we are using star. Okay, we call it as a dereferencing operator. Okay, so that as I mentioned you early in this slide, PTR is going to store the address. So address of var, address of the variable var. So address of the variable var is this is the address. So it is assigned to the variable here. Then the variable var will obviously contains the value of 10 because it is declared as integer and assigned value 10, so that it is storing the value as 10. Okay, so the address of the pointer variable PTR is this one, and the value of the pointer variable or content of the pointer. Please look at these changes. Where we are not representing simply as pointer, we are representing with the dereferencing operator as content of pointer. That means content of this particular address, the address mentioned in this 0x7ff like that. No? So this is the content. Okay, this is what the concept of dereferencing. Okay, let us get into the example. So look at this slide, this code where we have created the variable, we have defined variable value. Okay, so this particular variable value is going to store a value 100 here. So what will happen now? Now, due to the declaration int value equal to 100 means what will happen? This variable declaration statement will initially first it will create a variable of type integer with the name val. then it assigns the value as 100, right? So it assigns the value as 100. This is the representation. So now the value 100 will be stored in this. So now value 100 will be stored in this memory location value. Okay, then come to here, come to this location. Then we are just printing the address of value. For example, so you imagine that as per the memory location from the output we got. So this would be the address of the variable val, and its value is 100 here. Then just we are printing with the help of the format specified for percentage u, we are printing the address of variable. So this means what? It means that we are printing the address of variable val. Okay, we are printing the address of variable val. So that this output first prints the address of the variable val. The next one is just we are printing as like a normal variable. Okay, so like a normal variable, we are printing as like this, so that it will print the value as what? 100. Okay, then with the help of pointer dereferencing operator, we are printing. So pointer dereferencing operator means what here? Content of address of the variable val, right? The content of address of the variable val. So content of address of variable means what? Content of the address. What is the address here? 42902172 is the address here. So this particular dereferencing operator will print the content. The meaning here is the content of the address. Okay, content of the address mentioned. Okay, so that is what the value. So content of this particular address is obviously 100. So that here also you will be getting the value as 100. Okay, now you are all able to see the output as again 100. Okay, so this is a simple example to understand the difference between the address operator and also the referencing operator. So once again, I am letting you the name here. The ampersand is the address operator. Ampersand is the address operator, and star is the dereference operator. Okay, ampersand is the address operator. We call it as address operator. Okay, and star is the dereferencing operator. Dereferencing operator. Star is the referencing operator. So by the way, we are able to understand the difference between the star and ampersand. Okay, then why we are in need of using pointers? Usually, in order to return more than one value, from a function, we are supposed to use the pointer. Okay, so we have studied this application in a method of call by reference. Okay, so that by the way we are able to pass more than one value to a function, and we can return more than one value from the function. Then passing arrays and strings more conveniently, we can pass arrays as well as the strings to the function more conveniently. Then to manipulate arrays more easily by moving pointers to them. Okay, instead of moving the arrays themselves, we are going to move the pointers. Okay, then to allocate memory and access the memory in a dynamic manner. Okay, that is what we call here as a dynamic memory allocation. Then to create complex data structures. Okay, such as a linked list. Okay, linked list representation of queue. Okay, say linked list representation of the queue and stack. So along like this, we are able to do apply the pointer concept for the complex data structure like this. Okay, so then we are getting into the concept of pointer arithmetic. So pointer arithmetic obviously the meaning is we are doing some various kind of arithmetic operations here. Okay, so in this arithmetic operations of this pointer, we are able to perform increment operation, addition of integer to a pointer, increment and decrement operation, addition of integer to a pointer, Okay, then subtraction of integer from a pointer, then subtracting two pointers of the same data type, then comparison of the pointers. Okay, so arithmetic operation, pointer arithmetic here especially denotes the arithmetic operations that can be performed on pointers. Okay, so basically the pointer variable stores the memory. Okay, it is not basically storing the value, it stores the memory address of another variable. It does not store any value. So these are the some of the arithmetic operations we are going to explore. So out of these arithmetic expression, we will be exploring these increment, decrement, addition of integer, and also the subtraction we will be exploring here. Okay, so the first one is increment and decrement of pointers. So as like our normal variable, we can have the process of increment and decrement. So when the pointer is incremented, it actually increments by the number equal to the size of the data type. Okay, for which it is pointed. Okay, so when a pointer is incremented, PTR is incremented, it actually reflects the size of the data type. Okay, size of data type. So since it is pointing the address, so example, if you have taken as integer, so if it has taken as integer, then obviously its size is 4 bytes. So this pointer operation will increment 4. Okay, will be incremented 4 bytes. Okay, so this is what the increment operation. Okay, so look at this example. For if an integer pointer that stores the address 100, you please see, look into this example. We have a pointer variable. I am declaring it here. So I am declaring integer pointer. Then since it is pointer variable, I'm using dereferencing operators. And then as per this statement, I am choosing, I am assigning the address. So for this pointer variable, as per the statement, stores the address as 1000. Okay, stores the address as 1000. Then when it will increment by 4, which is the size of the int, then the new address will point to 1004. So when PTR is incremented as PTR plus plus, the pointer variable plus plus means instead of pointing the location 1000, now the pointer variable address is pointed, pointer variable will point to the address 1004. So now you all understand the reason why the value is incremented to 1004. Okay, so here the value is incremented due to the size, the integer size, right? So integer size is 4 bytes, so that it is getting incremented 4 bytes from 1000 to 1004. Okay, so this is the increment operation. Okay, so here, while if the float type pointer is incremented, then it will increment by 4. Okay, so likewise the pointer increment operation happens. Next, we are moving to the decrement process. So it is same as like that of pointer increment operation. Okay, so here instead of incrementing, the process will be decremented. The pointer is decremented. So it actually decrements by the number equal to the size of data. That is what already we studied. So it will decrement or increment based on the size of data type. So here in the same example, what we have seen initially, PTR, which is initially it was storing the value as 1000. When the pointer is decremented, PTR minus minus, then it will obviously reflect the changes that 1000, what will be the changes? 1000 minus 4, it will print the value as 99, it will get a value as 996. So now the pointer variable PTR will point the address, okay, 996 here. Okay, 996. So that So likewise, the increment and the decrement operation happens in terms of our pointer variable. Okay, PTR equal to 996 now. So initially it was 1000. So now the address is decremented. So based on the size of the data type, the address incrementation and decrementation reflect the changes. So let us look into this diagram. So we have a pointer with the value 1000 initially. This is an initial value. Okay, this is an initial value. When the pointer is incremented as p plus plus, pointer plus plus, then 4 bytes of memory incremented. Okay, 4 bytes increased. 4 bytes of address representation increased. When it is decreased, again 4 bytes decreased. Okay, 4 bytes decreased. So likewise, the pointer operation, incrementation and decrementation functions here. Okay, then addition of integer to a pointer. So suppose if we want to add some integer value to the pointer, what will happen? Okay, so we are all able to do some addition operations using pointers too. As mentioned here, the value, when a pointer is added with the integer value, then the value is first multiplied by the size of the data type and then added to the pointer. So let us look at this example. Same example we can take. So here pointer variable PTR, then initially its value is 1000, and we want to do a process called PTR plus 5. So what will happen now? Now PTR is initially contains value 1000. Okay, this is already existing value. Along with this, the size of integer and 5 will be added. Size of integer is 4. So 4 into 5 equal to 20. So you will be getting, 4 into 12, 10 will be 20. So that we will be getting a value as what? 1020. So 20 address of 20 bytes is getting increased. Okay, so here initially the same is represented in this example. This is the initial value where the pointer points 1000. Then when it is getting incremented with the formula, that is PTR plus 5 equal to PTR's base address plus 5 into 4 equal to 20, so that we are able to get the result as what? 1020. So this is an addition of integer to a pointer. Okay, then let us look into this example. So in this example, here we are simply declaring a normal variable PTR. Okay, so in this the variable name here is n. So what will happen now when you are declaring a variable of type integer n with the name n, there will be a memory allocated and it is assigned to the value 10. Okay, then I am declaring another one variable. So here I am declaring another one variable and its name is assigned as, name is given as PTR here. It is a pointer variable. Okay, then I am assigning PTR equal to address of n. Means what? PTR equal to address of n. So when we are looking into the address of n, we can see that we can take another address like, we can take the address as like 1040. For example, I am taking here as 1040 as like that. So if it is 1040, that address will be allocated to this pointer variable PTR. So PTR equal to address of n means what will happen? PTR will be, this variable PTR will pointing to the address of a variable n. That means it will store the address in its memory location 1040. You may consider this pointer variable's address as 1060 as like that. Okay, then next what we are doing is, so in this example, while I am executing in the data log, I got an address, or otherwise let it be 1060 as like this. So the value of n is %d. That means what? The original value of n is getting printed as 10. The next one, address of n is percentage x. We are using the format specifier as percentage x. Then address of n. Ampersand n represents the address of n. Ampersand n means address of n. So as per the original execution of the program in the data lab, the system is able to find the addresses at D71. So here I have taken 1040 as an example, but the original address as per the representation of the data lab is D71 A1504. Okay, so now this is the address stored in the value PTR. That means D71 A1504 is the address. So that it is printing the address of n is this one. Then address of pointer is pointer address. So here the pointer of address of the pointer given here is what? Just it is a value given in this pointer. Okay, that is means what? This is actually the address of pointer. Here this pointer, this may be simply content of or the value of pointer, you can take it. Okay, so the value of pointer means the value stored at the pointer. So the value stored at the pointer is obviously D71 A1504, which is the address of the pointer in. Next, the value stored in the pointer which referencing or which it references. Okay, so the value stored in the pointer where the pointer references, so that we can use the representation as star PTR. So content of PTR means the star PTR means content of PTR. So this means what? Content of the address stored in PTR. So content of the address stored in PTR 71 A1504. This is the value. Okay, so the content of the value stored in the address is what? 10. So that obviously this will return the value as 10. Okay, so we are able to get the output as 10 here. Okay, this is what the simple example for using pointers. Okay, then we will get into the arithmetic operation as like our normal addition and subtraction, multiplication as like that. So in this example, we have taken a variable, two normal variable as well as the two pointer variable. Okay, so here the pointer variable PTR pointing as like that is represented as like this: pointer C, another one is pointer D. Okay, so we can have any different name for the pointer variables. So this variable declaration, this part of the declaration statement initially creates a memory location as like this. As of type integer, its size is 4 bytes. Okay, its size is 4 bytes of memory. Okay, then here the name assigned here is A. Then another one variable, what's that? B is created, and also its size is 4 bytes. Okay, so this is the simple variable declaration. Then again, there are another variable name with the name C is declared. Similarly, the variable D also declared. Okay, then we are C is assigned to, so here we have C equal to address of A. Okay, so what will happen now? Here A may have its own address, right? So for example, I am writing the address of A as like 1010. Okay, then I am writing address of B as 1014. Okay, then what will happen? C equal to address of A means the pointer variable C will point to the address of A 1010. So that 1010 will be stored in this location. Similarly, we have another assignment definition, that means content of D. Okay, the pointer variable C here. Again, the pointer variable D equal to address of B. So what will happen now? D will point the address of the variable B. So here the address will be 1014. Okay, so this is what the case. Then we are reading the value of A and B. So we don't have any value, so we are reading the value. So in this example, while I'm executing, I have given the value as 34 and 56. So when I am assigning value 34, that is will be stored in the memory location of A. Okay, then similarly 56 will be stored at the memory location of B. Okay, so here the representation 56 is stored as like this. Then what we are doing here, we are since we have already assigned this pointer variable C and D to the address of A and address of B, we can do the arithmetic operation as like this. Content of C means the content of the address what it has, the content of the address 1010. So here 1010 is the address of A, right? So address of A. So the content at this particular address is 34. Okay, now you are all able to see here the content at this address is 34. So C, content of C will get a value as 34. Okay, the next one, the content of D means what? The content of D is content of the address. So what is the address of address stored in D? 1014. So what will happen now? The content of address D means 1014. So at the location 1014, we have the value 56. So now the computation content of C and also the content of B will obviously give you the value as what? Content of C plus content of D is equal to 34 plus 56. 34 plus 56. Obviously, we will be getting the value as 90. Okay, so this is the pointer arithmetic operation we are able to perform. So likewise, we are able to do various other operations, other arithmetic operations also. Okay, so let us look into this example where we are able to perform various operations like addition, subtraction, multiplication, as well as the division. Okay, so look into this example. Sum we are doing, that is addition we are able to perform, then subtraction we are doing here, and multiplication we are doing here, division we can perform, and modulo division also we can perform. Okay, so let us look into this particular line here. As usual, we are declaring variable for holding two numbers. So it is that variable names are given here as number 1 and another one is number 2. Okay, then similarly we are declaring another two pointer variables. Okay, so its memory location is assigned as like this, and their name is ptr1 and another one is ptr2. Okay, these are the two pointer variables. Okay, then we are, as usual, we are declaring the variables for storing the computed value, sum, sub, multiplication. Similarly, in the data type of float, we are creating div and modulo division. Okay, then we are reading the value of number 1, and similarly we are reading the value of number 2. So since I have executed these programs in data lab, while I am executing, I have entered value as 34. Okay, similarly the next value what I have given is 25. So what will happen now? Due to this initialization or due to this input, so the variable number 1 is storing the value 34 and the variable number 2 will store the value 25 here. Okay, will store the value 25. Okay, so this is what the case. Then what we are doing here, very important concept, ptr1 equal to address of number 1. So the variable pointer variable ptr will point the address of this particular variable 1010 like that. So that I am taking that 1010 will be stored here. Then its address you can consider as address of the another variable. You can consider here as I will choose another color. So here it may be 1014. So that the another pointer ptr2 is pointing the address of number 2. So this pointer ptr is pointing the address of number 2. So it will store 1014. Next, we are coming to the computation part. So these are the computation part. So what's the computation happening here? Sum we are calculating, sum equal to content of PTR1 plus PTR2. So obviously we know that. So that what will happen now? Sum equal to the content of PTR1. What is the content of PTR1? 1010 plus the content of PTR2. What is the content of PTR2? It is 1014. So that what you are able to get it here. So you will be getting 34 plus 25. You will get the result as 59 as the output of sum. Okay, so that is what printed here as sum equal to 59. Okay, similarly, we are doing some other operations also, subtraction. Okay, 34 minus 25. Obviously, we'll be getting the result as what? 9. Okay, here we are able to get the result as 9. Then multiplication. 34 into 25, we are able to get the result as 850. Okay, into 25, 850. Then division, normal division. So the quotient value it will be returning. So 34 slash 25 will return the quotient value as 1. Okay, so that so likewise, and also we are able to perform modulo division also. So very simple concept. We are all able to implement it easily. So thus, the pointer is very important concept. So pointer is basically a variable. It is also a variable, but it will holds the address of the variable. Okay, but it will holds the address of another variable. That is important point to remember about the pointer. Okay, then there are two important operators we are supposed to remind in our mind for a long time. So whenever we are about to work with pointers, so those two operators are one is one is a star operator. We call it as a dereferencing operator. So another one is address operator. Okay, dereferencing operator, and another one is address operator. Ampersand is represented as the address operator here. Okay, so that the pointer is very simple while we are observing these important points. Thank you.